As we discussed in our previous video, pop is very simple. First of all, when we try to check if stack is not empty, as long as it's not empty, it is eligible for pop. To do pop, when it is not empty, you only need this one line of the code, indicating that top will go to the previous location, which is top minus equals to 1. This line of the code is optional. It probably only makes you feel better. Before you reduce my top by 1, you want to say that that space, the array of that space equal to null. That line is optional, as I mentioned. If you have that line, it will change the space to -1 before it reduced by 1. If you don't do that, that's totally fine as well. Because even if you don't say that location equals to -1, that space can no longer be traceable. If you, after this pop operation, if you do a push, the value, my top, will plus equal to 1, which is locating at that location, and then it will override the value. If you try to do the top function, indicating you want to see what is the value on top of the stack, then you would just array of my top, which is the one that you already reduced. Let's take a look of an example. It will help you understand the whole process. So you can see that when we try to do a constructor, saying that int data type array, which is the name of the array, say 5, that specify our capacity equals to 5, it will create an array index from 0 to 4. Initiate top equals to -1, saying that this is an empty stack. So this is what constructor will specify. Define the name of the array, define the capacity, define where is the top location. When we try to do the push, since it is not full, which saying that top is not equal to capacity, the capacity is 5, top is now -1, so obviously it is not a full situation. So what we will do is simply top plus plus. So changing from top from -1 to 1 to 0, and then you can see top is actually at that location, and now we simply put the value, whatever that value, into the space, which you will put an A over here. And that is the idea of how we can do the push. So saying that if we want to push one more item, and right now over here, A and B indicating some any numbers. I intentionally leave it that way. So that since it is not null, top is equal to 0, capacity is equal to 5, all we need to do is top increment by 1. So top will changing from 0 to 1, and then we will put the value into that space over there. So that's what's happening for another push. Saying that if we want to do the pop, first of all, we will check to see whether or not this is empty. Obviously, top is equal to 1, which is not equal to -1, so this is not empty. All we need to do, like I mentioned, is top minus minus, so top will go to the index of 0 over here. This value, although it still stays over there, when we try to do a push, think about this. In push, this is not full, so top will increment by 1, and the new value you want to push will simply override this value. And therefore, without the line that I mentioned earlier in the pop, it actually doesn't matter. So that basically is the idea about how do we do the array implementation for the stack. You will see that if we try to do all of these operations, first of all, push A, you will see this situation. These are basically 3 examples that I show you in the previous 3 slides. Push B, you will see in this case, and we pop A, and if we pop one more time, then you will have one empty stack over here. So this is like the full process of what's happening over here. This should give you a very good understanding about how do we implement the stack through the array implementation. Of course, there are some problems over here. What if the capacity is no longer enough? Okay, so you see if the static array initially located for the state is too small, what can we do? one way, of course, is that we would be able to terminate the execution. The other one is basically replace with a larger array, so that we will be able to replace a larger array by creating a new array, of course. By doing that, we need to shift whatever elements that we have into the new array, and that would take some time to do it. And therefore, the next implementation is what we try to see. What if we want to do a linked list implementation? So for a linked list implementation, this is actually the simpler or the special case for the list topic that we discussed. Because remember, if we try to do the push or pop, there's only one place that we can do the push or pop, which is the very first location. And if you have a very good understanding about the previous topic, you know that whenever we try to do the special case, insert the very first location or remove the very first location are actually pretty simple. So that is the idea of what we can do using the linked list implementation for the stack operation. So you see that another alternative to allow stacks to grow as needed, which does not have the limitation of the capacity, we can use linked list. So linked list needs only one data member, so saying that pointer my top. In the beginning, all we need to do is initiate my top as a pointer, point at nowhere, indicating that's empty. And that is basically the constructors can do. So simply assign that. As long as my top equal to null, then we will be able to understand this is an empty stack. The top function indicating what's the value on top of it, we can simply say my top dash arrow data, and we can output that, and we will be able to get our top function. To do push, you see that this is again a special case scenario for the list operation, because there's only one place you can push, which is on top of it. And therefore, when you do push operation in linked list implementation, the only parameter that's needed is the value that you want to push in. So you can see that, say, this example is push 5, and what we will see is that we would first of all create a space. This is exactly the same 2 lines of the code that we have seen earlier. Create a new node. Remember what is the new PTR. Put the data value into the new PTR data. Basically, you see the 5 is going to be inserted over there. So that's the first operation that you will need. Next one is that new PTR next equals to top. So once we have this space, this is one, what I try to say over here. The next part will point at the current top. Whatever the top item is, originally this is the address of the first item. So we form this link, and then we say top equals to new PTR, and that's it. Now the whole linked list will start with 5. Element of 5 goes to 9, 17, and 22. That is as simple as the push operation using the linked list. For pop, again, it's the simple situation. All we need to do, first of all, using a PTR indicating that where is the elements that I want you to do. So PTR equals to top, indicating this is the element that I want to do. Then change my top to the next item. So my top equals to my top to the next. So my top is this one, my top next is this one. So it will make my top equals to my top next. It's actually the same thing if you say my top equal to PTR to the next, because my top and PTR are at the same address right now, and all we need to do last is delete, free the space. So that is how we will be able to do the linked list implementation. To show everything that we have over here, all we need to do is write the loop, make PTR equals to my top starting from the location, and as long as that is not equal to null, we will move to the next part, and then we can see our PTR to the data, and that way we will be able to get everything that we have. So like I mentioned, this is a simpler version of the list topics that we have discussed. In our next video, I want to talk about the vector implementation. This might be your first time seeing the vector. You can try to image that vector is more powerful, much more powerful array that you have known, because it has all the functionalities array have, and plus it has many useful functions that we will be able to see.